So in this video, we're going to learn how to solve some basic exponential equations. So if we take a look at example 1, we have 3 to the x plus 1 is equal to 9 to the x. So what we want to think about for equations like this is, can we rewrite 3 as some power of 9 or 9 as some nice power of 3? And it's going to be easier to write 9 as some power of 3, and I'll show you guys how to do that. So we're going to keep 3 to the x plus 1 as it is, and we're going to rewrite 9 as 3 squared, because 3 squared is equal to 9. And now what we're going to do is simplify the exponents on the right side of our equation. So remember that when we're raising a power to a power, we're going to multiply the exponents. So 2 times x is 2x. So we get 3 to the 2x. And now we can tell that we have the same base for both of our exponential terms. So if the bases are the same on both of our exponential terms, we can just set the exponents equal to each other. So we can just say that x plus 1 has to equal 2 to the x. And now we can solve this pretty easily. We're going to subtract x from both sides, and we're going to get that 1 is equal to x, or x is equal to 1. Taking a look at example 2, we have something similar. We have 5 to the 2x plus 3 is equal to 125 to the x plus 2, and we're going to do the same thing. So we can rewrite 125 as 5 to the third power, and we're going to keep the left side of our equation as it is. So we're going to have 5 to the 2x plus 3, and now we want to simplify the exponent on the right side. So we keep 5 to the 2x plus 3, and we're going to multiply our exponents, so 3 times the entire quantity of x plus 2. And now we're just going to simplify a little bit more. We're going to distribute the 3 to get 5 to the 3x plus 6. And now, because the bases of our exponent are the same, we can just set our powers equal to each other. So we're going to say 2x plus 3 is equal to 3x plus 6. We're going to solve this. I'm going to subtract 2x from both sides of my equation. Oops, not 3x. 2x. On the left side, I'm left with 3. On the right side, 3x minus 2x is x. So I have x plus 6. And then we'll go up here to finish solving. So we have x plus 6 is equal to 3. We're going to subtract 6 from both sides of our equation to get that x is equal to negative 3. Let's go through some more challenging examples. So if we take a look at example 3, we have 4 to the 3x is equal to 8 to the x minus 4. And you may notice that we can't write 4 as some power of 8, and we can't write 8 as some power of 4. So what we need to think is, can we rewrite them both as some power of the same number? So we can write 4 as 2 to the second, and we can rewrite 8 as 2 to the third. So now both sides of our equation will have the same base. And now let's simplify the exponents on both sides. So we're going to multiply that 2 by the 3x. We're going to get 2 to the 6x. And we're going to multiply this 3 by the x minus 4. So we're going to get 2 to the 3 times the quantity of x minus 4. And we just want to simplify that exponent on the right a little bit more. So we're going to distribute that 3 to get 2 to the 3x minus 12. And now that our exponents have the same base, we can just set our exponents equal to each other. I'm going to say 6x is equal to 3x minus 12. I'm going to subtract 3x from both sides. I get that 3x is equal to negative 12. And we'll finish solving this up here. So we have 3x is equal to negative 12. Divide both sides by 3 to get that x is equal to negative 4. Moving on to example 4, I encourage you guys to pause the video and try this one on your own, and then you can watch me work through it to make sure that you've solved it correctly. So we have 1/16 raised to the x minus 5 is equal to 2 to the x plus 10. So we have a fraction on the left side. So what I would do is try to think, can we rewrite 16, so not 1 over 16, can we write 16 as 2 to some power? And you may realize that 2 to the 4th is equal to 16, which means that 2 to the negative 4th is equal to 1 over 16. So we're going to rewrite 1 over 16 as 2 to the negative 4th, and that's raised to the x minus 5. And then this is equal to 2 to the x plus 10. And now we want to simplify the exponent on the left side. So it's going to be 2 to the negative 4 times the quantity of x minus 5 is equal to 2 to the x plus 10. And we just want to distribute on the left. So we have 2 to the negative 4x plus 20 is equal to 2 to the x plus 10. And now because the bases of our exponential terms are the same, we can set the exponents equal to each other and solve. So we have negative 4x plus 20 is equal to x plus 10. And now we want to get the x's together, so I'm going to add 4x to both sides of our equation. On the left side I have 20. On the right side I have 5x plus 10. I'm going to subtract 10 from both sides of our equation. And I'll write the answer up here. So 20 minus 10 is 10. This is equal to 5x. And finally, divide both sides of our equation by 5 to get that x is equal to 2. Let's go through a couple more examples. So for these next two examples, we can't really easily change one of our bases of our exponents into the other base. So I'm going to show you guys how we can solve these a different way. So we take a look at example 5. We have 4 to the x is equal to 5. We can't really write 5 as 4 to some nice power, and we can't really write 4 as 5 to some power. So what we want to do is take the ln of both sides. You can also take the log of both sides, but I think typically teachers teach you to take the ln of both sides, so that's how I'm going to do it. So we're going to take the ln of 4 to the x is equal to the ln of 5. And remember that ln is just log base e. So now what we have to remember is this rule that says if the input of our log is being raised to a power, we can kick that power out to the front and just multiply it by our log. So we can rewrite ln of 4 to the x as x times ln of 4. And this is equal to ln of 5. And now to get the x by itself, we can just divide both sides by ln of 4. So we get that x is equal to ln of 5 over ln of 4. And I'm just going to leave my answer like this. If you guys need a decimal approximation, you can just put that into your calculator. And finally, taking a look at example 6, we have 3 to the x is equal to 2 to the x plus 1. So again, we can't really write 3 as 2 to some nice power, and we can't really write 2 as 3 to some nice power. So we are going to start by taking the ln of both sides. So we have ln of 3 to the x is equal to ln of 2 to the x plus 1. And now we want to kick both of these exponents out to the front. We're going to have x times ln of 3 is equal to the quantity of x plus 1 times ln of 2. And now what we're going to want to do is keep the left side as it is for now. And we want to distribute this ln of 2 into our parentheses on the right side because we're trying to get the x's by itself, so we have to get the x out of that parentheses. We're going to have x times ln of 2 plus ln of 2. And now we need to get our x terms on one side, so we're going to subtract x ln of 2 from both sides. And we're just going to write it as x ln of 3 minus x ln of 2 is equal to ln of 2. And we have to factor this x out to get it by itself. So we're going to have x times ln of 3 minus ln of 2 is equal to ln of 2. And finally, divide both sides of our equation by this entire quantity of ln of 3 minus ln of 2. And we'll write our answer up here. So we're going to get that x is equal to ln of 2 over ln of 3 minus ln of 2. And I'm just going to leave my answer like that. So hopefully this video helped you guys understand how to solve some basic exponential equations. If you want some more practice with problems like this, check out the link in our description for a free practice worksheet.